everyone to my channel. My name is Oluwashim, and we want to continue from where we stopped on our project. Today we will be building our EKS cluster. All right, because we need to deploy the application that we have built onto the cluster and see how it runs. So far, we've looked at the microservice application, and we've seen all the 11 project. I've walked us through the 5 different programming language, what the pipeline looks like, and I believe that you can actually use that idea to build the other microservice application. And we've published all the images into the GitLab container registry, and that is where Kubernetes is going to be pulling from in order to deploy our application. Okay, so here we're going to be using Terraform to deploy our EKS cluster, and I'm going to be leveraging the Terraform module, that is available on the Terraform registry. So that's what I'll be using in order to speed things up. Of course, you can actually build your own EKS cluster from scratch. That's very possible. Okay, the only thing is that sometimes it can take you some time to actually do that, because of, there's a lot of things that is involved when it comes to Terraform, But if you want to build your own EKS cluster from scratch, that is very possible, You can leverage, like I said, the Terraform AWS, the documentation is actually there. You can follow that through. And of course, you can leverage AI to assist you, in putting that together as well. But don't forget to fact check that with, the documentation, so that you're doing the correct thing. So here, I'm going to be using the EKS module provided to us by AWS as well. So here, I'm going to be using this. And we're also going to be using the EKS, add-ons. Okay, we're going to be using that as well. So let me see, EKS. We're going to be using all of that, okay, as well. Let me just look for add-ons. It's not giving me what I want, okay, but that's fine. So we can actually go over here to modules. And we can look for AWS modules. Okay, and we're also going to be leveraging the VPC module as well. Okay, so I'm going to open up all of these things that we'll be using. So I'm going to open them up. So these are actually, custom built modules that we can actually use out of the box without any much modifications. Okay, but if you do want, you can actually modify and, okay, so see the name here. So there's the blueprint EKS. I think is it blueprint? So not sure. Okay, so let me search for. So there are actually 2 of them. Yeah. So there are actually 2 of them. So there's the add-on and there's add-ons. So this one is, I believe this is the one we're using. All right. So we have the EKS module, we have the VPC module, and we have the EKS blueprint. All right. And so these 3 modules, it's what we're going to be using primarily. Now, one thing I want to explain here is that I wanted to take note of something. And while I was working on this, I, came across that. And for me, it was really an eye-opener. And I wanted to share that with us. Okay. Now, when you're using a module on the Terraform page, now there is a section here called dependencies, right? Now, these dependencies basically will tell you the other module or the other providers that this module actually depends on. For example, EKS depends on VPC, depends on KMS, a lot of things that it depends on, right? Now, one thing you must notice that, for example, this module, the latest version here is 21.1.3. So that's the latest version of this module. So let's say you want to use this latest version. Now, if you come here to dependencies, it tells you, it says module dependencies,
Now, dependencies are external modules that this module references. It says a module is considered external if it isn't within the same repository. Okay, so now in order for you to use this module, right? Of course, it requires KMS 4.00. Right? That's fine, but the thing that I want to open your eyes to is actually this provider dependencies. Now, EKS, it's a module provided to us by AWS. Okay. Now, AWS is also a provider as well. All right. And then you also have the cloud init, which is also a provider. You have the null, a provider. You have time, another provider, TLS, another provider. Now, this is where you need to pay attention, very closely. Now here, in order for me to use this EKS module, it means that my provider, the version of my provider must be greater or equal. If you look at what I have, it says greater or equal to 6.9, which means if I'm using AWS provider of 5.99, for example, that means I won't be able to use this module with that provider's version. Okay, now that version is valid, but if you want to use this module, okay, to spin up an EKS cluster and you're using the latest version 21.1.3, then it means that your AWS provider must be of the version 6.9 greater or equal. So which means anything below 6.9, right, will not work with this particular module. Okay. And the same thing applies to cloud init. So it has to be 2.0 greater or equal, null 3.0 greater or equal, time 0.9 greater or equal, TLS 4.0 greater or equal. Now, that is something that I really need us to pay attention to, okay? Because sometimes you use a module and then you're getting some errors, you don't know what's causing the error. But I mean, while I was working through it, I came across some errors and then I realized that there was, what you would call version incompatibility. Okay, so I was trying to use this latest version, and then I was using a VPC that is not, that does not support this particular version. Okay, so that's one thing I wanted to pay attention to. Now, if you come here to the VPC as well, the VPC, the latest version of the VPC is 6.0.1, right? So if I scroll down, of course, there's dependency, and it says this module does not have any external dependency, but it does have, a provider dependency. Okay, and that provider dependency is 6.0, which means if I want to use this module, okay, with this version, then my AWS provider cannot be less than 6.0, which means if I'm using the AWS provider of 5.9, 5.100, and all those kind of things, then I won't be able to use, this particular module. Okay, so let's note that. But another thing here is this. Now, if I come back to my EKS and I say that perhaps I want to change my version, right? So let's say we're going to be using, let's say this 20.3.72, right? So let's say that's the version I want to use. And by the way, this version is actually the should I call it the last stable version, if that's a correct word to use. All right. Now, if I choose this version and I come here to dependencies, all right. And now, if you look at the provider dependencies, now you can see that the parameter has changed, right? The requirement has actually changed. So for the AWS, I can still use something that is greater or equal to 5.9, which means if I'm using the AWS provider version 5.100, 5.99, then I'm good. All right. But it has to be less than 6.00. Okay, you can see that. And then you can see that these other ones actually also remains. So that one requires, the use of the Kubernetes provider. That this is something that was not in the latest version, right? That the latest version does not require the Kubernetes provider, but this actually requires the Kubernetes provider 2.20, and this one requires 2.0, 3.0, 0.9, 3.0. Okay, so that is something that you need to note. Okay, and if I go back to the VPC as well, let's say I change this back to 5.21, for example. Let's say that's the version I want to use. All right, I can come here, come to dependencies, and I can see that these has two dependencies. Can you see that? Two dependencies, which means you can use it with, AWS provider version of 5.79 or greater, or 5.83 or greater. So basically, anything that is greater than 5.79 or equal to 5.79, then you can use this version with that. Okay. So that is one thing that I thought to share with us. And of course, if you look at the add-ons as well, if you go to dependencies, that has a lot of dependencies. Okay, it has a lot of modules dependencies. It has a lot of maybe not a lot of provider dependencies, but I mean, you do have some dependency here. So you can see this one requires AWS version 5.0 or greater, right? That's okay. And then Helm, because your EKS add-ons, right? This one actually uses Helm behind the scene to install those add-ons, all right, onto your cluster. Okay, so which means you must have Helm as one of your providers, right? So you must have that. And of course, it requires Kubernetes as well. It requires the random, right, HashiCorp random 3.6, time 0.9. Okay, so that is something that we need to pay attention to very closely. And I thought I'd share that with us because while I was, preparing for this video, I had to do a few research, and then I came across this, and it was eye-opening, for me, because I've encountered that error before, but while I was preparing for this video was when, it actually made a lot of sense, to me. All right. So let's just know that just in case you are using, any of these modules, just be sure that, the provider dependencies, the versions are compatible so that you don't run into unnecessary, all right, issues. Okay. So now that is that on that. So let's take a look at the what the pipeline looks like. Now, before we go even to the pipeline, let me just mention something here. Now, if you look at this architecture, we're going to be using the EKS add-ons to install the AWS Load Balancer Controller, which would allow us to use the application load balancer. And there are two things we want to use the application load balancer to do. The first is to, of course, we're going to be setting up the Kube Prometheus stack that would give us Prometheus and Grafana. And so our Grafana, we want to virtualize, of course, we want to be able to access it on the browser, and we want it to use HTTPS instead of HTTP. All right. So we're going to be balancing that as well. And we want that to use HTTPS, which means if I do Grafana dot whatever, it should return back a secured site. All right. And number two, our online boutique application, the front end, which would give us access to the boutiques, all right, to the store. We also want that to be secured as well. So we want to use HTTPS for that. So that means we're going to need a valid, SSL, all right, for us to use. And so the first thing we're going to do is to use Terraform to quickly set up SSL, all right, as well, so that we can actually use that with our load balancer, so that by the time we deploy the EKS, we deploy our applications, we can actually access, our applications on the browser with HTTPS instead of HTTP. Okay. And one more thing that I need to mention before we start deploying is that now this AWS Load Balancer and then, of course, the Kube Prometheus stack, we're going to be leveraging the M repo. All right, for that. So let me just type M repo here. So there's what you call the artifact orb. This artifact orb, it's a place where you can find quite a number of Helm charts that have been pre-built that you can actually use out of the box, which means you don't have to reinvent the wheel. You can actually just pick some of these charts and use that to deploy some of these resources. So we're going to be leveraging the Kube Prometheus stack. All right. I hope I got the spelling right. Okay. Let me take a look at that image again. Kube Prometheus. All right. Maybe the spelling is not right. All right. So we have Kube. All right, so there you go. So we're going to be using this one. There are two of them actually, right? There's this test OCI repo. That's not the one. And there's this other one as well, but this is the one that we're going with because this looks more like the one from the organization, right? You can call that the verified, provider version, right? And if you look at the stars, it has about 1,000 stars, and these ones are just private, the ones that people did and then published as well, just like when you push something to Docker Hub, right? So this is what we're going to be using. And if you come here on this page, you would see the install template default values, and of course you would see the versions. So as of the 23rd of August, the latest version is 77.0.0. All right, we can actually use that as well. And if you come here to default values, it will tell you some of the values you can override. Okay, some of the values you can override. You can also search for those things here. Okay, so we're going to be leveraging that. And then we're going to be needing the AWS Load Balancer Controller. I think we're going to be using this one. So you can see that you have, a couple of things here with the same name. So you have to be sure the one you're using. So we're going to be using this one. This one is from AWS, right? This from the repo directly. We're going to be using that one. And of course, the version we have here is 1.13.4. That's as at the 4th of August. And of course, if you come to the default values, it tells you the values, and some of these values you can actually override them as well. For example, if I type region here, I can see region here, and region does not have any value, so I need to supply that if I want this to work. VPC ID, I need to supply that as well because it doesn't have anything, so you need to supply those values in your pipeline. So these are things that we're going to be using. And like I said, of course, it uses Helm behind the scenes. So I'm going to show you everything that we have in the pipeline. All right, the CI/CD pipeline that will do this for us. I'm going to show you all of that. And of course, for the AWS Load Balancer Controller, we can actually also see something here. So I want to take us to, so if you go to this page, I believe that's the page. All right, so if you go to this page, now if you are someone who has done a few things with Kubernetes, you will know that in Kubernetes, there's what you call annotations, right? Basically, if you come here, to scroll down, let's see deployment, I believe under deployment, or if we can't find it under deployment, then we should be able to see it under guides. Let's look at configuration. So installation guide, subnet discovery, I'm not sure that's where it is. All right, let's click on guide. All right, so on the guide, we have annotations, right? And of course, on AWS, there's a new features now that is called the EKS Auto Mode, all right, which basically helps to simplify infrastructure management and all those kind of things. Your instance scaling, health check, others. Anything that has to do with your infrastructure, right? The EKS Auto Mode can help you undo that while you focus on your business logic and code and all those kind of things, right? So it's the new feature on AWS. So these are annotations, and we're going to be using, quite a number of things from here, because it is with annotation that we're going to be able to map our certificate, our ASIM certificate to Kubernetes, and then tell the load balancer controller to basically use that certificate, all right, to, for our applications, right? So that the applications can be accessible via SSL. Is that okay? So we're going to be using a lot of these annotations right here. Okay. So that's what I wanted to share with us. So I think we can go in now and then just let me walk you through the pipeline and let's deploy the EKS and let's see, how far we can go with that. All right. But before we deploy it, like I said, we need to create a certificate that we're going to be using. So I just put, I put together, something which you can get on the Terraform registry page. If you go to Terraform registry, if you search for, let's go back to providers, AWS. So if you come here and you search for, all right, so, okay, if you search for ACM, you'll see that option here. So basically, this is the example usage, right? So you can see that from here. So just copy that and put it here. So let's quickly use this. So I have a domain already that I purchased from GoDaddy, which is teachdev.online. So that domain is here. If you have Route 53, you can actually use Route 53 as well. If that's what you have, that's also okay. But then, the GoDaddy domains, you can buy some cheaper domains for like maybe $1, something cents, which basically is cheaper than Route 53, because there's no domain you want to get on Route 53. I think the least there, if I'm correct, should be around maybe $10, $11 a year. But you can get, some domain names here for $1, right, for 1 year. Okay, especially the ones that end with .xyz and the .online domains, right? Those ones are very cheap. And of course, for the purpose of what we're doing, learning, I don't think you need to
you need to spend, $10, $11 to buy a domain, right? I mean, you can go with the one that offers you $1, I mean, just for the purpose of, the name, right? So nothing more. Okay, so I'm going to go to my managed domain. So I don't have anything much there. I mean, I don't think I have anything set up yet. So we can just use that. Okay, just to basically ensure that our Grafana dashboard is accessible with a very beautiful name, and our boutique store is also accessible with a name that is that is readable. Okay, so that's the purpose of this. So this is the domain, *teachdev.online. Now the reason for the asterisk is basically to cover every other subdomains as well. So if I'm going to have online boutique.teachdev, the certificate should also cover that. Okay, so that's why I have asterisk dot, so that any other subdomain that that I want to have, the certificate should well cover all of those as well. All right, so let me basically quickly export my key here, since I'm deploying this locally. So I'm just basically going to say Terraform apply. It's something I've checked already. So inconsistent log file. Imagine I'm trying to do Terraform apply. I've not even initialized my repo. Can you imagine? I'm not even initialized my Terraform. Can you imagine that? Terraform init. Apologies for that. Good. All right, so let's do Terraform init. So that will initialize the configuration. So the initialization is actually completed. So now I can do Terraform plan. So let's see what that will give us. Okay. So here, basically there's something, just one thing we're adding. And then we need to print out the domain validation option. So that will give us the record name, the resource record type, and the resource record value. Okay, because we're going to need that to validate the domain, because the validation method is DNS. So we need to copy those things and create a CNN record on our domain, right? And so we're basically printing out, those outputs. And of course, the ARN of the certificate, we need to print that out as well, because we're going to need that for the EKS cluster. All right, so I'm going to say Terraform apply. All right, so Terraform apply. And that would create the domain for us. It shouldn't take time anyway. It's just one resource. So let's see what that gives us. All right, good. So here we have the ARN. So this is a certificate ARN. Okay, we're going to need that for our Kubernetes cluster, like I mentioned. And then the domain name is this, the resource record name is this, and then the record value is this. So we need to copy this value. So I'm going to copy this and go to my domain. And of course, I'm going to add a new record. And the record is going to be a CNAME, like we can see here. It's going to be a CNAME record. So CNAME, so the name is going to be this. But actually, you can remove your domain name. And just leave this. And of course, the value is this. I'm going to copy that. All right, and put that here. So we can change the TTL to time to live to 1 hour. All right, so okay. Now, sometimes it can take maybe a minute or two, but it doesn't take time really to validate. So once you have everything copied and everything is correct, you can actually go to your console and go to ACM. All right, you click on Certificate Manager. Okay, so that would take you to the Certificate Manager page, and you basically can access and see your certificate right there. So if I go over to the domain, I can see that the record has been updated, all right, successfully from here. And if I go to my certificate manager as well, I should see, all right, the options as well. So if I come here, I can see the name. I can also see the value. All right. And of course, if I come here, I should see all right. So here it says pending validation, right? So it's pending validation. So if I click on it, it shouldn't take much time. So, but we just have to wait for this to be, validated. So we'll come back to this, and just check later on. But the most important thing is now we have the domain, it's still pending validation. We've copied this already to our domain controller, our domain registrar. So hopefully it gets done very quickly. All right, so let's take a look at the EKS infra that we're going to be using and the Terraform configuration that we're going to be using to set up our EKS, cluster. So here, by now, I want to believe that we're familiar with CI/CD already, the GitLab CI. I want to believe we're familiar with that. So we have the init stage, we have the validate, security scan, plan, apply, and destroy. And I'm going to be using my custom image that I created that has AWS, Kubernetes, kubectl, and Terraform, bundled together with it. Okay. And of course, we have these variables, which I believe we saw. I think I mentioned this to us in the OIDC section where we created the OpenID Connect for GitLab, right? So we have all of this there. And then we have the OIDC configuration here, which is basically to get our token from AWS, short-lived token, since we don't want to use access key and secret key, which is actually not best practice. So this really is best practice, all right? And then, of course, we have the init stage that will do the Terraform initialization. And of course, we have our tags properly configured. And then we have the Terraform init, the backend configuration. And of course, we have the validate phase to validate our configuration. And of course, we have the security scan. Okay, now the purpose of the security scan here is to use checkoff to scan our Terraform configuration to be sure that the configuration follows best practice and there are no vulnerabilities. All right, so that's why we are integrating checkoff into this. And the good thing about the checkoff is that for the checkoff report, it actually publishes its report in XML, and that means it's something we can actually visualize without having, any ultimate subscription and things like that. We can actually check that report in the test, page on the pipeline page. We can actually see it there. So we'll see if there are errors, the success rate, the failure, the errors, and all those kind of things. We're going to be able to capture that. All right. And of course, checkoff, it's a tool by Prisma Cloud. Okay, you want to check out a site. So this is a site here. I've accessed it a couple of times while preparing for this. So here is the documentation. All right, you can see the CLI command reference here. And then most importantly, you can also see what it supports. So under integration, you can see for GitLab CI. Okay, so you can see also you can use it with GitHub Actions, Jenkins, and all. So for GitLab CI, this is the example here, but you really don't need all of these ones. All right. And then, of course, that's the script, checkoff-d, 0, blah, blah, blah. So you have that. So checkoff-d, all right, download external modules equals to true because we're actually using, what do you call it now? We're using, Terraform modules directly. Okay. So, and those modules are not things that we created locally. So we need to tell checkoff to download external modules so that it can also scan the modules as well. So that in case those modules contain errors or vulnerabilities, we can also see that and then, decide whether to use it or just, build our own EKS infra by ourselves. Okay. So that's the purpose of this path right here. And of course, we have the Terraform plan, we have the Terraform apply, okay, which will do the apply for us. And here we also have these shell scripts that would be doing some health check, all right, for us as well on the Kubernetes cluster. Okay, that is written in shell script. If you look at it here, it's basically going to be doing, we have the namespace, we have the monitoring cluster name, region, then of course EKS, kube config, and then it's basically just going to verify the cluster that the cluster is ready, all the endpoints. All right, everything is ready. So you have the check ALB controller ports, you have the kubectl get port. The idea behind this health check thing is basically to ensure that the ALB endpoint, it's up and running, that everything is fine, so that we can access our Grafana and then our application, all right, as well. So that's the purpose of all these commands that you see here. But basically just to check
that the cluster is okay and everything is in the ready state. Okay, so that's the purpose of that. And then of course you have the destroy job. So now I'm going to walk you through the EKS configuration. So we have the local, we have main output provider, and we have some Python script here, which perhaps I'll talk about later. And here, let me open up the Terraform first, the Terraform.tf. So here, of course, you can see that we're using the backend of HTTP, which I believe you're familiar with already. And here we have the required providers as well. So we're using AWS now. Going back to what I showed us earlier, you can see here that the version we're using is 5.95. Okay, in order to avoid that, issue with, version, VPC, the AWS provider and all. So we have the version 9.5 here, which will work with our VPC and the cluster as well. Okay, and then Kubernetes version, we also have 2.3, but that's kind of variables, which means it can be greater than 2.3, but not less than 2.3. All right, and that would also still work as well. And then for Helm, because I told us that the EKS add-ons actually behind the scene uses Helm to install, those tools onto your Kubernetes cluster. And so we need to specify that version as well. And so here we're using the version 2.17.0. All right, now these are versions that I have tested, and of course it works. But if you want to take the learning here a step further, which I actually encourage you to do, you can try, higher versions, latest versions, and see, the result you get. But of course, you might have to do a little troubleshooting, but I believe that that's okay because, that would help, you to learn, a few things as well. And then, of course, we have the provider as AWS, all right? And here, of course, we have the provider expanded here. So here, the Kubernetes provider, we actually have to expand it, and that's because there are certain things that once the Kubernetes cluster is up and running, there are certain things that we want to execute, right? We want to install Argo CD, we want to install, Argo CD, all right? We're going to be doing that later in another video. But we want to install the AWS Load Balancer Controller. We want to install Prometheus and Grafana stack, those kind of things. We need to authenticate with the cluster in order to be able to install those things onto it. So that's the purpose of these, Kubernetes provider, the host. The host here is basically referencing the cluster endpoint, which of course will be an output, all right? An attribute reference. And then of course the cluster certificate is something we can also get from the cluster as well. So, and then the exec command is basically to execute certain commands, all right, on the cluster, and basically the AWS commands, right? So AWS commands and all of that. And then of course we can see the argument. The argument is EKS, get the token, all right, and of course from the cluster name as well. And the same thing applies to a Helm, because the EKS add-ons, like I said, uses Helm behind the scene to perform its installation. So we have the Helm provider as well. So we're specifying basically the same thing like we did all right here as well. So these two are necessary in order to authenticate with the Kubernetes cluster and of course install those add-ons onto the cluster. Is that okay now? And then of course we have the locals. So the local here is to define a few things. Number one, availability zones, right? Because we're using the VPC, all right, modules. We want to be able to make sure that we have the subnet across all the zones. And we're also using locals here to compute some of our values that we already know beforehand. And one of them is the name of the cluster, the region, the versions. We're using the version 1.33. Of course, we have the 1.34, but 1.33 is like the latest stable version. So we're going with that. And then the VPC CIDR, that's the CIDR we have. And here you will see that we don't have any subnet CIDR because we're actually going to be slicing the VPC CIDR using the CIDR subnet function offered us by Terraform. Okay. And then we have tags here, basically. So if you come back to the main TF, so the first thing you will see here is availability zones. Let me see, is that not a duplicate? Okay, so, all right. So this one, all right. Okay, so this one is for this. Okay, good. All right, so availability zones, all right, easy. So we have the module VPC. I can see we're using the 5.2, and that's also variable. So which means it can be 5.21, it's 5.22, and all that, but nothing less than that. All right, and then we have the version, then we have the name. So we're using local.name VPC, then the CIDR. We're basically using local.vpc CIDR, right? That would refer to this. and then ASIS, basically local.asis, right? So if you look at this place, we have local.asis, that's what we're using. And then of course, we're using the slice function, which will extract some consecutive element. So in that region, we have 3 zones. So we want to use all the 3 zones, okay? We're not using a single zone. If we were to be a single zone, we'll have used element instead, right? Element will give us, just that, a single element, all right, in that list. Okay, but this is a list as well. So we're slicing and then getting all the 3 ASIs that are available to us. Okay. And then here we have the private subnet and we have the public subnet. And then of course we're doing some for each here. So we have for KV. So the K here there is the key. V there is the value. Okay. So local.asis. Now local.asis here, it's going to basically give us 3 availability zones. So that means we have 3 things. All right, 1, 2, and 3. Okay. Now CIDR subnet is equal to local VPC CIDR. Now, if you hover your mouse on the CIDR subnet, it says here, the way to use it is that the prefix string, which is a VPC CIDR. So that's the 172.1/16, right? And then the next thing that follows after that is the new bit number. Now, the new bit number is what do you want, what's going to be the next CIDR, all right, the next slash, all right, the next CIDR, slash notation, all right, because if you look at what we have here, we are using /16. Okay, so for the subnet, are we also using /16 or we want to increment that? Okay, because on AWS, there are reserved IP addresses and all. So here we have 4. So that means the subnet are going to have a slash notation of /20. Okay, that's what that means. And then the last one there here says, all right, net number. Okay, the net number here, we're using K for that. So K there is the key. And the key here is the number of ASIs that we have. And what's the number of ASIs we have? We have 3 ASIs. So that means this is going to generate for us 3 subnets for all of the ASIs. Okay, I believe that explanation makes sense, right? So for K, V, so K is the key, which is the number of ASIs, right? 1, 2, 3. Okay, and then V there is actually the value of the ASI, which is EUS1, EUS2, EUS2A, EUS2B, EUS2C. Okay, now we cannot use EUS, those letters to generate subnet, right? Because we want to create 3 subnets. All right, so what you would use is the key, not the value. Okay, so the key is in numbers, right? 0, 1, 2. So that's 3. So we have the VPC /16, incrementing that to /20. And of course, the K there is 3 things, is 1, 2, and 3. And so that would give us 3 subnet, all right, across the 3 availability zones. Now, if you look at a public subnet, there's a little twist here. So we have the same thing, but we now have +3. Now, if you leave the K without the +3, it's going to give us the same exact, all right, subnet range, but that's going to cause a problem. All right, so we have +3. So that means we're saying that we already have, the 3 subnet across the AZ. So give us another 3, all right, subnet range for the public subnet. Okay, so that means we can have one that will be 16, another one will be maybe 0, 16, 32. Then we are going to have 48, 64, 96, and things like that. Okay, so that's the purpose of the +3. So which means we're saying give us 3 new, all right, subnet across the AZs. Okay, so that's what we have right there. And then enable NAT gateway, of course, EKS cluster should be in the private subnet, then the worker node should also be in the private subnet, and then single NAT gateway true, because we don't want to have it, NAT gateway in each of the zones. That'll be a lot of money, and that's not necessary. Now here we have the public subnet tag and we have the private subnet tag. Now, when you're deploying your EKS on AWS, now these 2 things are very important, particularly for your load balancer. All right, if you have the intention of using a load balancer with your EKS cluster, which I want to assume that you will use, then these 2 options are non-negotiable, because without this, your load balancer will fail, okay, when you deploy it into your cluster. It doesn't matter whether you're using the AWS Load Balancer Controller, whether you're using the Nginx Ingress Controller, these options are very important. And let me show you where I got that from. So if you come here to the documentation and you look for AWS EKS, let's say VPC, all right, and then you click on this option, you will see in the documentation clearly stated that if you want to deploy a load balancer in your Kubernetes cluster, then those two tags are of utmost importance. All right, they are not negotiable. So let's go through this documentation together. If you come here, let me scroll down to where it is. Okay, so VPC and subnet requirements. So let's click on that. All right, so let's scroll down here. Okay, so now it says if you create a cluster with this, all right, you should add the following tags, but that's not what we're looking for. All right, so let's still scroll down. Subnet requirement for nodes. All right, it says here, if you want to deploy load balancers to a subnet, the subnet must have the following tags, right? So it didn't say here whether it's AWS Load Balancer Controller, whether it's Nginx, ingress controller. It says if you want to deploy load balancers to a subnet, the subnet must have the following, all right, tags. And so that is where that tag came from, all right? So, I mean, this is something that ChatGPT might not be able to give you, or any AI platform that you're using, okay? And that is why I always emphasize that going through the documentation is very, very important, all right? Because this information ChatGPT might give you eventually, but you'll have done a lot of texting, a lot of chatting, okay, before you get to this. But from the documentation, you already know, okay, I'm deploying load balancers, this is the requirement, then I need to add that to my configuration. And also, if you go to the Terraform documentation, these options are not there as well. So, but if you see it here, you can incorporate that into your configuration. So that's where we got this from, and that's why we're using it. All right. So the value here is 1, and of course you have this other one shared. So you can see that we're using that across both the public subnet and the private, all right, subnet. That's where we got that from. And so that's that for the VPC. Okay. Now here we also have the EKS module. So I'm using the EKS module 20.3. All right. And of course, I want this to depend on the VPC because I want the VPC to have completed, all right, before I deploy my EKS cluster. I don't want them running, concurrently. Okay, so then the cluster name, the cluster version, the cluster endpoint. Now, all of these options that you see here, they are things that you can actually get, on the page as well. So if you go to the VPC, go to the README, you can find all the examples, right here. If you go to the EKS and you go to the README as well, you can see all of the different examples here. In fact, with the EKS auto mode and all, you have that right here as well. So everything was gotten from here as well. All right. So we have the cluster name, cluster version, cluster endpoint public access equals true because we want to be able to connect to it locally using kubectl. And then, of course, the VPC, the subnet ID, we don't want to create security groups. I mean, you can enable that anyway. It doesn't matter. And then here we also have enable cluster creator admin permission equals to true, which means the user or the role that creates, or created the cluster will have access to the cluster as well, right? So that's what this means. So if you are the IAM user that created the cluster, then you should be able to have access to the cluster, all right, that you created. Okay, so that is set to true. And then some cluster add-ons that we need. So core DNS, and if you look at where we were using most recent, we want to install the recent versions of this. And we also have the EKS manage node group, and we have the instance type, we have the minimum and the maximum size and all that. So I'm using T3 medium so that at least it can accommodate all the tools that we want to install. Okay. And of course, for the EKS blueprint add-ons, that also depends on the module EKS, right? So the EKS cluster must have been completed before the add-ons will work. Now, if you look at the add-ons we have here, so we have the cluster name, the cluster endpoint. Everything is being fetched from the EKS module. We're not coding anything. And then we want to enable the load balancer controller. We want to enable Carpenter. For now, we don't need Carpenter. Carpenter is for your node scaling, right? When you want to scale your nodes, you can use Carpenter for that, right? But we don't need that for this. And if you want to know the things the add-ons you can enable with the EKS add-ons, you can actually do that from here.
We can see them. So these are the add-ons. So there's Argo CD, EFS, I mean, a lot of them. All right. You have the Carpenter version, Ingress controller as well. You have the Kube Prometheus stack. You have metric server, Velero to back up your cluster. You have the VPA as well. All right. And you also have the AWS Load Balancer Controller. I mean, you have a lot of things that you can enable here. Okay, so that's where we got it from. And so what we're going to do now is to expand these options that we have. All right. So enable load balancer controller, it is true, but there are default values that we need to now, supply values, all right, to. Okay, so we can't use those values as easy, right? We need to supply the correct values for those parameters. So the chart, of course, it's coming from the Helm repo. So if you go back to the Helm repository that I showed us earlier, we're at DAO, okay? So this is the load balancer controller. The version is 1.34. So that's the version we have. The repository is this. So the repository URL is always somewhere here. Okay, so you can actually grab that, I think, from here. So that's the repo. And then the namespace, this should be installed in the Kube system namespace. And of course, we have some options here to wait. The purpose of the wait is that we want the load balancer endpoint to be ready before anything gets deployed, since we're going to be using Grafana and all. And of course, we want, the VPC and everything to be in the ready, state and all. Therefore, we have this wait and then wait for jobs equals to true, so that we don't want to have any kind of error, or maybe, we'll start restarting services and all those kind of things. We don't want to go through all of that, okay? And then values, we have YAML and code. And remember, your M chart, all right, the values that the YAML is actually, all right, a YAML file. So you're going to use YAML and code, not JSON and code, okay? So the cluster name, we need to supply the cluster name. So if you come here, all right, to the default value. Okay, let me quickly show you that. So if you look at cluster name, you would see that perhaps the cluster name is empty. So if I click on cluster name, I can see that the cluster name is empty. So I need to supply that, because if I just deploy like that, then the question is, which cluster does he want to deploy to, right? So you need to supply cluster name. Region is something you have to supply as well. So region, you need to supply that. VPC ID, you need to supply that. You can see that this is empty. Replica count, you can leave that, and you can supply that as well. But I can remove that, or let me just leave it. So you need to supply these three values. They are very, very important: the cluster name, the region, and the VPC ID. All right, these three things are very important. Now, for the Kube Prometheus stack, we also need to supply some values. So here we have the chart. We're using Kube Prometheus stack 76.40. We can change that to the latest version, actually. So let's try the latest version, Kube Prometheus, all right, stack. So there you go. So the latest version here is 77.00. All right, 77.00. Let's give that a go. All right, I like to try new things. 7.0. All right, 0.00. So let's try that. So this is the repository URL, which we can actually get from here as well. You can see the URL right here. Where are you? All right, so this is the URL, right? Prometheus community GitHub chat. So that's the URL, namespace, monitoring. So this one, we're not deploying it in the Kube system namespace. We're deploying this in another, all right, namespace. So we also have the wait for jobs here as well. And of course, we have some encoding too, right? So Grafana, now the admin password, there's actually a default password, but we just feel, okay, let's not use the default password. So let's use another one. So if I come here to admin password, grafana.admin password, I can see that it has a default password called prom operator, but I'm just basically writing that with something simple. But the good thing about Grafana is by the time you go into the dashboard and you put this default password, it is going to prompt you to change it before you continue, all right, with the Grafana, all right, platform. Okay, so that's the good thing about that. And then, of course, we have Ingress. So here we want to basically tell Grafana to use Ingress, okay? So Ingress here, so if you search for this too, you're going to see that as well. Ingress, so you're going to see that Ingress should be Grafana Ingress, I believe. So Grafana.ingress. So we can see that. So enabled is false. So by default,
it is false. Okay, so which means it is not enabled by default. So here we have enabled equals to true. So we're using that. So ingress class name. Here we should have ingress class name. So here we have ingress class name, but the default here is Nginx, but we are using ALB because we're using the load balancer controller. So the class name is going to be ALB. And then we have annotations here. So if you scroll down, so you can see annotations right here, but the annotation is also very empty. So we need to start, putting different annotations that we want to use, all right, there as well. Okay, so here we have these annotations. So we have the ALB, all right, .ingress.kubernetes.io. The scheme is internet facing. So if you go to the documentation right here, where is it? All right, so you can see all of these things here, right? So, so here we have the load balancer name, right? Of course, we have the scheme. So the scheme should be somewhere here. If you scroll down, you'll see the scheme. So the scheme here is internet facing. So that's what we're using. And of course, the target type, of course, is going to be IP, not instance, right? In this case, it's going to be IP. And the certificate ARN as well. If you look at what you have, the certificate ARN. So we can copy this to search, Control F. All right. So you can see certificate ARN. So it can be a list of strings, which means you can have more than one certificate, right? It doesn't have to be a single certificate. Okay. So this ARN has to change. You remember? So I have to look at the one we deployed. So this is the ARN. So I need to copy that ARN. Okay. So then come back here and basically remove this. And then, of course, I will have to use the updated one. So that'll be the certificate ARN. And then here, we're specifying the listen ports as well. So if I copy this, all right, I can actually also take a look at that. So the listening ports, so basically that will specify the port that the ALB listens on. And this is the default, right? This is how to go about it. So you can see some examples here as well. So 80,443, and that's exactly what we have here. So port 80 and 443, right? We're using both of them. And here we also have the SSL redirect. So which means if anybody accesses our site using the port 80, all right, the load balancer should automatically perform a redirect, to port 443. All right. So that's what we're using this one for. And then, of course, we have the group name. Basically, we want to have just a single load balancer to handle the Grafana request. And of course, our application as well, we want the same load balancer to handle both of them. Okay, so that means we're going to have two target groups and then a single load balancer. All right. So one target group for your Grafana, another target group for your online boutique. But of course, we're using a group name for both of them. So that means the two applications will be under the same load balancer, but different target groups. Right. And then we have an health check path here. Basically to be sure that our instance is the load balancer returns LD. All right, so that's what we're trying to check. So health check path. So we can have all of these options that you see here. Okay, so we have that. And then, of course, we have the health check interval stuff that we usually do with the ALB. And then the host, we're saying grafana.teachdev.online. But by the time you set up this, your load balancer controller will generate for you the load balancer endpoint. And so we have to go to our domain, put the endpoint, and then put the name Grafana. All right, so that it can be grafana.teachdev.online, right? So we need to do that. And that's pretty much, all right, what I would want to explain to us about the, all right, EKS. So this gives you a complete, all right, EKS setup with your load balancer controller, with your Prometheus dashboard, certificate configuration and everything, right? If I want to do my node auto scaling, all I need to do is just to include Carpenter, do the configuration and deploy, and that's pretty much all that needs to be done. So right now, I'm going to commit these changes, all right, to the repo, and then let's build, let's execute the pipeline, let's create a cluster, and let's see, all right, what we will get. So I think the pipeline file is okay already. And the main.tf is also good. All right. So I've been able to walk us through all the things we have here. So I'm going to go back to the console and then make sure that my instance is up. All right. So let's go to the EC2 instance and let's bring up our runner because we're using our own runner. So I need to start it up. So instances, and I need to start on my own. So I'm going to come here, start instance. All right, so that will start up the instance. And of course, I need to check my project here. Go to settings, CI/CD. And two things I need to check here. Number one is the role ARN. So here I have the role ARN. Now this role ARN must be the ARN of the OIDC that we deployed, right? So I can come here and take a look at it. So 6 says, I think it's the same. So we're good. So that has to be there. And of course, I need to check the runner as well. All right. Okay, so the runner has been enabled for this project already. Okay, so that's good. So we just have to wait for this to come up. All right, so it's still initializing. Hopefully, if it comes up, it should turn green. All right, so it's green. So I think we're good to go with our deployment. So let's push this to the repo. All right. Setting up EKS cluster. Oops. All right, so we're pushing to the repo. And we can actually go back and check. So let's go to build pipeline. That should have triggered the pipeline, right? All right, so now this is going to take a while. Okay, so I'm going to pause my video at this point and allow this to run. And then once it gets to apply, we need to manually trigger that. So once it gets to apply, I would, come back, we'll do the apply together and then allow these, all right, to run. Okay, so it's going to take some time because, it's going to take, the EKS cluster should take around 20-30 minutes thereabouts to set up. So I'm just going to pause my screen. Once that is done, then we can come back, review the security scan together. Then we can apply the configuration and we move, all right, from there. Okay, so thank you so much, guys. So here we have the init job. And that actually passed. And then we have the validate. That also went very well. Okay. And of course, the configuration is valid. And we have the security scan, which is the checkoff. And obviously that also, there were errors, but we have configured it in such a way that it won't fail the pipeline. So these are some of the reports that it came back with. All right, we're going to look at that shortly. And then we have the Terraform plan. And this is where we're going to see what exactly it's going to be deployed. And these are the different outputs that we expect. And here we have about 60 things that will get deployed, right? It's going to deploy 60 resources. Well, that's quite a number. All right. And then if you come here, so from here, you can actually see the check of reports. So here you have the test. And this is from checkoff. And there were about 926 tests that was carried out. So if you click here, there were about 553 failures and 926 tests, but there were 53 of them that failed. But it has a success rate of about 94.28%, which still it's kind of fair. 94%. That's on the high side. And of course, you have 873 of those tests passed, and that's what gave us the number 94.28. So if I click here on the security scan, I can actually see some of the ones that didn't pass. And of course, it will give you the description here to know what you need to do. So this one says ensure the CloudFormation stack sending blah blah blah. Terraform module sources use a commit hash. Ensure Terraform module use this. Use a commit hash, and that's kind of the same thing that I'm seeing here, right? It's kind of the same thing, right? This is commit hash. All right. So that's the security report. So you can see that. 94% success rate. That's a good one. So now that we have the plan and all, so I can go ahead and do Terraform apply. All right. So I'm going to click on the play button. So that will, start the deployment process. And these, like I said, can take another 30 minutes. All right. So I'm not going to sit here and watch it. I'm just going to go and do something else and then come back and, we'll review the apply job together. All right, is that okay? So let's just wait for this to run and then I'll come back. Welcome back, guys. It seems like our cluster is ready. So let's click on the pipeline. Let's review what has been done. So I already showed us all of these up to the security scan and plan. So let's take a look at the apply job. Let's see exactly what it did. And of course, interestingly, it took about 16 minutes and 31 seconds. I mean, I thought it was going to take, because sometimes it takes longer, right? So it took just 16 minutes and 31 seconds. So this is everything that was created. Of course, we can begin to go through them one by one. That would take some time. But you can see it from here. I mean, everything right here, and then everything got created. So apply complete, 60 resources have been created. So this is the cluster endpoint. This is the cluster name, the OIDC provider ARN, these are the subnets, and then of course the VPC. And also we have the health check, the script that I put together, so that to basically just make sure that the ALB load balancer endpoint is running. And we can see here verifying cluster connection. Kubernetes control plane is running at this and this. Core DNS is running at this. To further debug and diagnose cluster problems, use kubectl this, and then checking ALB controller ports. So we can see that our ALB controller is actually working. And then waiting for ALB controller to be ready. So we can see the conditions were met, and we can see that, I mean, we have some endpoint. The Kube Prometheus stack is also ready. And of course, we can see our load balancer endpoint right here. Okay. Can you see that? So our load balancer endpoint is right here. So we can actually create the CNAME record, all right, for this particular host and access Grafana dashboard. And that means if I come to instances and I go to my load balancers, I should actually see the load balancer that was just created right in this on the console. So let's wait, let's see. That should come up any moment from now. And of course, if I open up the target group as well, so let's go to target groups. Let's open that up also. All right, so we can see here the target, the load balancer is active, and we can see that it's deployed in the 3 availability zones. So if I click here, I can see the rules, all right? So this rules was created because of the annotation we specified. And of course, you can see the redirect as well. So it's going to redirect to 3.1 permanently. So it means anybody that accesses the site on HTTP, then it redirects them back to HTTPS. And we can actually see that it uses the certificate that we created together earlier. So that's what it's using. So we're going to copy this DNS name, go to our domain. We're going to add a new record, and it's going to be a CNAME. So we're going to put the value here, and the name is going to be, so we can call this Grafana, all right, because that's the name that we gave here. So it's going to be grafana.teachdev.online, right? And this is the load balancer's, all right, endpoint. So we're going to save that. So we can change this to 1 hour, save that. So once that is saved, we should be able to access the Grafana dashboard, because, I mean, the health check we have here basically has told us already that, I mean, everything is fine. We don't have any errors, right? Everything deployed successfully. Okay, so this is still, so the DNS record has been updated now. So it means that if I go here now and I do Grafana teach dev.online, so you can see that I'm not specifying any HTTPS or anything. So if I press enter, then if everything is fine as per the configuration that we did, we should see here that it actually redirected back, all right, to HTTPS. So here it says connection secure. If you click on the certificate, you can see that it's actually using the Amazon certificate that we created. And of course, we created it just now, so 25th of August, just right now, as at the time I was recording this. And of course, we can see that it was issued to this particular URL, right? To teachdev.online. So like I told us already, I mean, everything that comes before the teachdev, the certificate will also cover that as well. So we can see Grafana bouncing. So it's going to give us the dashboard page, and of course we'll be able to log in and then, you know, start creating dashboards and visualizing what we have then. So I'm going to log in here. The username by default is admin, and of course the password we supplied was admin. But of course, like I told us, it's going to prompt me to change that password. So as you can see here, it says before I can continue, I will have to change the password. So here I have to put a new password. Okay, so all right, and then of course I would submit. So it would, of course, the password has changed, and I can see here that of course my Grafana is secure, like we mentioned. It's going to be using the certificate we created together. And right here, I can actually go to dashboards and then, just pick one or two dashboards here to see, all right, my cluster. So I can click on this one, and that will give me some information about my cluster. So you can see CPU utilization, CPU request, memory utilization, all this, good stuff. You would see them in there. And of course, you can see your namespaces and the number of ports that each of them have. All right, so you can see all of that. And then, of course, you can see, a lot of things here. A lot of statistics that we have here. Now, we have deployed EKS. EKS is working, Grafana is working. We can access the Grafana dashboard. We can see the data, we can see the metrics and all. But remember, if I want to administer these, these cluster locally, okay, how am I going to do that? Because remember that in that configuration, we basically said something here. If you look at the main TF, in the main TF, we said enable cluster creator admin permission. So which means this cluster was created with the GitLab OIDC role, right? So the meaning of that is it is only the GitLab role that can actually access the cluster. Right? I can't access the cluster. For example, if I come here now, let's say I try to, let me just give us an example. All right. Let's say that, let's take a look at this. Right. So let's say that I want to, if I come here, I can try this command, AWS EKS, so let me initialize my configuration. So my credentials rather. So AWS configure, all right, list. So let's take a look at that. Okay, I don't have any configuration. So let me export to my credentials. Now remember, my credential is actually tied to this particular account. So let me initialize that. So AWS profile. Okay, so let's see. All right. So now if I do the AWS EKS, all right, AWS EKS update Kube config, and remember you must have your kubectl installed locally, right? And then I specify the region as EU West 2. Okay, and then the cluster name, which is the name. So the cluster name is, let me look at the name here. I think we printed out that. So, all right, so this is the cluster name. So if I grab the cluster name like this, and then I come back here, and then I press enter. Now I'm going to get an error, all right, because now it says what? Added new context. Okay, now it added a new context, right? So now let's try kubectl get nodes. Okay, so let's see if we're able to access, all right, this cluster. Okay, so let's see. Okay, so we have an error here. Now it added the kube context, but it's giving us an error. Okay, because it says the server has asked the client to provide credentials. Okay, so because this user is not a user who created a cluster, the cluster was created by the GitLab, OIDC, which is the role, which means only the role can have access to the cluster. So what are we going to do? Because I can't be running kubectl right from the CI/CD pipeline. Okay, so but I want to be able to access my cluster locally, perform some operations, and then if there's anything I really need to do, I can go back and access that. So what is the workaround for this? Right. So what can we do? How can we work around this and still be able to access the cluster with this user? All right. So what can we do? All right. Now this is what we can do. So I'm going to go back to my OIDC. Okay. That's where we need to make the change. So I'm going to go back. I'm going to do git branch -a. And then I'm going to do git checkout. all right, AWS underscore IDC. Okay, so I'm going to check out to that branch. All right, and what I'm going to do is in the main section where we configured, all right, these particular statement, principal, all of these things. Now we need to configure another statement and then another principal. Okay, so how do we go about that? So here I'm going to say another statement here. Okay, and that statement is going to have, of course, effect. It's going to be allowed. So we're going to allow that, right? So I mean, I can just copy everything here like this. So just copy that. So just copy. What did I copy? All right, effect. Now, what are we actually allowing? So we're allowing this STS assume role. Now we want the user, all right, our IAM user to be able to assume this role as well. So it's not going to be the OIDs, the GitLab that can assume this role. We also want our user to assume the role. So the next thing I want to do here is I'm going to copy this one, the principal. So the principal, what is that going to be? Okay, think about it. What's the principal going to be? So the principal, so this is going to be AWS, obviously. Okay, it's not federated. Now the identifier, what's the identifier going to be? So the identifier is going to be the IAM user, ARN. Okay, so let me go to IAM, go to IAM here. So the identifier is going to be the IAM, right? So I'm going to go to users. All right, so I'm going to click on this user and I'm going to copy this ARN. So copy the ARN of the user and we're basically going to put that here. All right. So now we're basically saying here that, I mean, this user can assume the role. All right. So if this user is able to assume the role, then of course, automatically the user has access to the permissions, right? And the user can perform whatever it is that the user wants to do. Is that okay? So you have the allow, STS assume role, type is AWS, and then of course, this is the user that we want to allow to assume the role. Okay. So the next thing we need to do now is to update the OIDC to include this option. Okay. So I'm going to come to my CI/CD here. All right. And then I have my GitLab configured already there. So all I need to do is to basically just come back. So I'm going to say git commit. All right. Adding IAM user to GitLab OIDC role. Now, this might not be the best approach, okay? But I mean, this gives you access to to administer your cluster locally using that particular user, okay? Like I said, it might not be the best, method. Of course, there are other things you can do. You can configure the config map AWS auth, right? That's also another option. Okay, you can do that, but I mean, just to work around those things that we're doing here, we can actually leverage this option so that our IAM user that has the admin access can as well assume that role. Okay, so that's the approach that we're looking at. Okay, so let me see. Do we have the part configured? All right, so I can actually check my pipeline configuration here. Anyways, I don't have to go to the browser. So I can see what's going on here as well. So the init phase is running. So this should not take much time because what we are applying is just, a modification that shouldn't take too long. So, but then let's see what this gives us. Okay, so, all right, validated running as well. So let's see. So want to change. All right, so there's one to change and this is what it wants to change. Okay. So it's changing that. And then let's apply. Let's trigger that. So that should trigger the apply job. So
So that has been modified. Okay, so if we go to the roles now, let's take a look at what we have. So this is the role. And then we have to look at the trust relationship. Let's see. All right, so now we have the effect as allowed, we have the principal, and we have action STS as the role. So we have that. So the user should be able to connect to the cluster now. All right, so let's give that a go again. I don't have to switch back. Okay, I can use this terminal as is. And all I need to do is just to export my credential again. All right, and then I can actually, now remember the option here is assume role. Okay, so it means that the user credentialing alone is not enough. So that user must assume this role, all right, in order to be able to access or administer the cluster. But of course, the first thing is to, make sure that your credential is configured first, right? We have the credential. Then after this, we can actually now perform the assume role option. Because now if I do STS get, AWS STS get -color -identity. All right, so I can see here that it's going to give me the identity of the current user. Okay, so we can see the identity we have. Now, by the time we assume the role, we should have another identity. And so here I have another shell script put together. All right, so that would, so this is a role ARN. So I'm going to have to change this name, and then the session name, the cluster name, all right, echo assuming role. And then of course we just want to use the shell script to perform the assume role option. So this role ARN needs to change. So the role ARN is this one. So I'm going to copy the new one here and replace that with this. Okay. And in order for us to run this, we're going to use this command. So I'm going to say source dot assume role.sh. Okay. Now the purpose of the source is to make sure that that credential is made available in my current session. So if I press enter, so it's saying assuming role. I remember the first thing I did was to configure my keys first, and then I will use that to assume the role. So now if I do the STS get color identity again, then the ARN should change. You can see that the ARN has changed. So that tells me that now I have actually assumed the role. So now if I do kubectl, all right, get nodes. Okay, so I should be able to get my nodes now. All right, there you go. So we don't have any error again because this user has been able to assume that role. And of course, that role is the only role that has access to the cluster. So now that we've assumed it, we can actually manage, all right, our cluster right here and now. And if I do kubectl, all right, get pod -a, all right, that should show us all of the ports that we have in all the namespaces. And right here, we can see that, all the ports, everything is ready. Okay, we don't have any error, we don't have any problems. And as we can see, even from the Grafana dashboard, everything seems to be okay. We don't have any issues, all right, whatsoever. All right, so that's good. So the next thing now is to deploy to deploy our boutique application to the EKS cluster. All right. So that's the next thing that we would have to do. Okay. So we can keep this here. Of course, sometimes the assume rule, it's for 1 hour. So I believe that before that 1 hour, we should have deployed our application to the cluster, all right, access it from the cluster, and then we should be able to delete all those things within, 1 hour, all right, so that we don't exceed that. Because after 1 hour, you'll have to, renew the token, all right. So, but I believe you've learned something very important here now, right? How you can assume a role, and all this kind of stuff. All right. So that is that. So Let's go here. So I'm going to come back to my project and I'm going to look for the Helm project. All right, so I'm going to click on Helm. So this project is actually, if you look at this project here, we have the stage, the package, the mlint and all. We have everything here to deploy. So it's also going to do the EKS kube config. It's going to create a namespace for us. And it's going to also do the kube, get secret and create, a Docker secret for us that will be used to pull images, from the container registry of all of the projects, And if you look at what we have here, we're basically using a token. So we have the CR registry, the CR registry user, but then we have a token that we have created to, that has the ability to connect to all of the project, because the container registry is actually for each of the project, And we're not going to be pulling for each of the project. So we basically created an access token, at the, repository level. All right. So here, if you go to access token, so we created this token called, called Helm read registry. Okay. And this Helm read registry, it's basically, it has the scope of just reading the registry, which means just fetch images from the registry, Anything other than that, it doesn't have that. Okay. And that's the only thing the Helm project just needs to be able to read container registry. So with this token, we will be able to read the container registry of all of the project and then pull those images and deploy them to our Kubernetes, cluster. So that's the idea behind, this one. So what I'm going to do is that, so since this would only run in the main branch, and of course it can only be triggered manually, so we can actually just, do that right here, okay? So we have everything we need. So let's go ahead and do this. So I'm going to come to build, come to the pipeline, and I'm going to come here and say a new pipeline, So I'm going to do a new pipeline, or I can actually go to the last one we did, which is this one, where we merged into that branch. And I can actually come here and then click on the plus sign. So I think this should work as well, but it might not, but let's see. The reason why I said it might not work is because if I go to settings and go to CI/CD, I expected that to fail, because of the role error. So if I come to CI/CD to variables, I don't have the role ARN. I've not updated that here. So I need to come back here. All right. If you see, the role ARN is different from what we have. So we have to quickly come back to that, grab the correct one. All right. And then let's put that here. And let's save the changes. Okay. So now that we have saved the changes, we can build again. So I can go back to the pipeline. This is filled. I can go back to this one that actually failed and I can do a retry. All right. So I can actually do a retry. So let's retry it and let's see what this will give us. Okay. So let's retry. So that has actually deployed the old stuff. If you look at what we have, it says microservice chart does not exist. Installing it now. The secret key was created. All right. The namespace was created. Pretty much everything was created. All the services, everything also was created. And the second job, which is to verify. Okay, so that also needs to be triggered manually. So let's run that as well. So the purpose of that is just to verify that the applications have been deployed and there are no errors and all that. So that's the purpose of this verify. And we can actually do the same thing here as well locally. But let's just do this. Okay, so the verify job is also trying to run. So let's see what that gives us. All right, so let's see. Okay, we can see that all the services are running actually. Right, if you look at it, everything is running. The last one is the load generator, which is initializing already. And like I said, we can actually check it locally as well. So I can come here and do kubectl
get pod. The namespace that we created for that is online boutique, right? So that's the name of the namespace. I can copy that and then say, give me all the pod in this namespace. Okay, so it's going to give us the pods in that namespace. So let's take a look. I have all the pods in the namespace. If you look at what we have, these are all the pods. I mean, everything is running. And so that means if I go to my Grafana dashboard now, the load should have increased a bit. We can see the CPU request count has increased to about 53.6%. And then we have about 73.2%. The commit limit, memory utilization has jumped up. And if I come here, I can see the online boutique right here, and it has 12 ports, all right, in total, right? So if I click on it, we can actually see all the ports that are running there. I can see these are all the ports, all right, that are running, and everything is good, doing okay. So you can see the utilization, you can see the limit, memory, and all of that. So everything is running as we expect. So I mean, the load balancer, we want to check that. So we can do kubectl, all right, get ingress. The namespace is online-boutique. Okay, so we want to see the ingress. Okay, so the ingress is this onlineboutique.teachdev.online, but it does not have an address. What could be the issue? Why does it not have an address? Right? I mean, it should have an address. Okay, it should have. Let's see that again. So what could be the problem with this? Oh, okay. So why does it not have an address? Why does it not have an address? What could be the issue with that? All right, so let's troubleshoot this together. I think I know where the problem is, but let's look at it together. All right, so why does it not have an address? So if I go to my all right, so let's go to the Helm job. So this is Helm. Let's go to the Helm repo. And let's come here to the microservice charts and to the values.yaml. So let's look at this values.yaml. Okay, so here, the certificate ARN here is this, which is not the same as what we have. All right, so we would have to redeploy this. Okay, so we need to change the certificate ARN. Remember, we have a new ARN, and this is not it. So let's go to this. I believe you understand what I'm saying. So let's go to the EKS infra. All right, let's click here. Because if it doesn't have an address, that means we can use the load balancer with it. So I believe that that's where the issue actually came from, that ARN. So let's look at this certificate. Oh, okay. We deploy the certificate locally, right? So, all right, yeah, deploy it locally. So let's copy this. So this ARN that was missing. And so let's put that back here. All right, so I'm going to have to edit this manually, even though it's not appropriate. But I can actually do that locally as well. Okay, and then push it to the repo. So let me do that. Down. Yep. All right, open the file location. There you go. All right, so let's update the values.yaml. All right, so we need to change this. I want to believe that this should work. All right, so that has been changed. So let's quickly push this again. Okay, certificate ARN updated. All right. So let's push this. Oh, yeah. So there's some git pull to do. That's fine. Okay.
Good. All right, so let's push. Okay, all right, we've pushed to that repository now. So let's come here. Remember, the pipeline is not going to be triggered because it has to be triggered by another pipeline. And what we did is a push. So that would not give us that, that pipeline thing. It's not going to give us that. All right. So you can see that we don't have any pipeline here because the configuration is that the commit, it should be a pipeline source. Okay. So let's just merge it straight away. And so once we merge, we're going to run the Helm deploy job again. And hopefully, let's hope that it will, make that correction. Okay. And if it doesn't make that correction, then we might have to remove the chat and redeploy it again. Okay. This is taking some time. All right, so it's here now. Okay, so let me run this again. I sincerely hope that this will, help us correct that. It was an oversight, so let's hope it will correct that certificate stuff. That issue that we have. All right, so it's running now. It's trying to upgrade. So let's see what that does. Okay, so the upgrade is completed. So let's verify the deployment. So we can verify from here, and we can also verify locally as well. Okay, so let's verify locally. Let's see if the address is coming up now. Let's see that. Okay, so you can see that now we have the address. Okay, and of course we can see that here as well. So yeah, we can see that. So now it was that certificate mismatch that caused that problem. So we've been able to resolve that. Okay, so we can see the address now. So we can actually copy the address here and copy from here, go to our domain and then create another record and put the value here. So it's going to be a CNN record. Put the value here and the name is going to be online boutique, right? So let's copy the name from here and we can put it here. So this can be 1 hour and then we can save. So this way it's going to give us pretty much what we want. All right. So now we have that configured. Now, if you look at the load balancer, let me just quickly show you the load balancer. If you refresh the load balancer, you would see usually we should have 2 target groups, right? We should have 2 target groups. And so one for the boutique application of signed out. So let me sign in again quickly. Loading, I can actually come in and just do online boutique.teachdev. So that should redirect to the boutique. All right. So yeah, you can see the logo also has changed here to show that we deployed this on AWS as well. So it's telling, this basically tells us that this was deployed on AWS, and we can see the boutique application right here, okay, using the certificate that we also have, deployed. And we can see that every aspect of it actually deployed correctly. So if I click on this one, I can make an order for sunglasses. Maybe I need like 4 of it. Add to cart. We can see that the cart is updated, right? With quantity is 3. And of course, we can see all the information right here. You can change the date to April 2028 to put your card number. All right. And then, of course, the address can be updated. All of this can be updated, the country, and all of that. So you can empty the card as well. So you can see the functionality is working. And for the currency service, which is responsible for all of these different currencies that we have. So if I change this to pounds, for example, I can see that the price was updated. So that tells you that the application is actually very, it's functioning. So if I change to Canadian dollars, I can see the prices change. If I change to Japanese yen, I can also see the price change. So that tells you that there's communication amongst the services. All right. And if I change this one to euro, for example, I can see that. So if I click here, I can add like 10 of these to my cart. All right, and then I can continue my shopping. Okay, to basically go and pick, another item. So let's say I love this watch, and then I can select this, add it to the cart. All right, and once I'm done, I can say place order, and then it tells me my order is complete. Confirmation email sent, and then of course it generated, some confirmation ID, which is the function of the load. All right, generator. All right, that's the function of the load generator. Is that okay? So that's the function of the load generator. So, guys, I think we've done a fantastic job together, and it's so beautiful to see us bring this architecture to life. All right, it's such an honor, it's such a privilege for us to bring all of these things to life, and I believe strongly that we've learned a lot. All right, in this particular series. I didn't plan it for it to be this long, but I believe strongly that we've learned a lot from these series. I mean,